This is Troy Hawk, and we're going to graph the inequality that we see here. Y is less than or equal to x plus 5. Here we can start by graphing the intercepts. So I'll graph the y-intercept by letting x equal 0 and solving for y. So we have that our y-intercept is plotted at 5. Then we can go and graph our x-intercept by letting y equal 0 and then solving for x. So here we subtract 5 on both sides, and that will give us x is equal to -5. We can plot that on our graph. One thing that we want to keep track of is the type of inequality that we have. Well, we have a less than or equal to. So when we connect our graph or connect our line, we will have to consider that a less than or equal to gets a solid line. So when we graph it, we connect the points with a solid line. Now the next thing to consider is the shading. Remember that when we're working with inequalities, one side of the graph gets shaded, one side of the line gets shaded based on the type of inequality that we have. Again, this is a less than or equal to. Well, and we're talking in terms of y. So y is less than or equal to x plus 5. So since it's less than, we shade the area that is under the line, less than y, so under the line. So here, under our line, will get shaded accordingly. So here we see that below the line is less than or equal to. Now, if this had been an inequality that said y is greater than or equal to x plus 5, then of course we would shade the other side of the line because that is where y is greater, meaning that we're going to, as y gets larger, the shading will grow higher here. We can always test points as well. So for instance, if we tested the point, let's say right here we tested this point 1, 0 for x, 1, 0 for x, 1, 0. So 1 is x and 0 is y right at this point right here. If we plug that into our equation, where again 0 was y and x was 1, we would see that 1 would become less than or equal to 6. So that is true, which makes this shading true. So any of these points that we try over here will work for us here. Even if we substituted in -4 for x and 0 for y, so -4 for x and 0 for y, again we see that this is true. But when we go beyond -5, let's say for example -6 comma -6 comma 0, where again x is 6 and your y is 0, we will see that this will not work out. So again, 0 for y and 6 for x will leave us with -1 on -6 for x will leave us with -1. 0 is less than or equal to -1, which is not true.